My name is Makeda Tamrat, and today I'll be speaking about stem cell research and its role in potentially curing type 1 diabetes. A little bit about me: I'm a rising senior at Bishop O'Connell High School, and I aspire to become a stem cell researcher and pediatric endocrinologist in the future. This August, I'm excited to have 2 upcoming research publications in partnership with my local university, working with Professor Espina in a proteomics CAP-CLIA laboratory, and another project with Dr. Hakami focusing on immune system response mechanisms. Beyond the lab, I serve as a youth advocate and congressional delegate for Breakthrough T1D, an experience that allowed me to testify at Capitol Hill for the importance of continuous support of diabetes research. I have also founded and led an advocacy group at my school, now in its 4th year, which works on spreading awareness and promoting education on various autoimmune conditions. In addition to my scientific interests, I'm the president of my school's ASL Honor Society and an active participant and teaching assistant in choirs at my school and a director in my community church choir. The breakdown of this presentation. First, what is type 1 diabetes on a cellular level and the epidemiology of type 1 diabetes? Second, what stem cell therapy is and the processes behind it? And third, how stem cell therapy is being utilized to eliminate type 1 diabetes successfully? And lastly, the contributions. In order to understand the implications stem cell therapies are having on type 1 diabetics, we must first understand what exactly type 1 diabetes is. Type 1 diabetes is an autoimmune condition where the body mistakenly attacks beta pancreatic islet cells, which produce insulin, a hormone which allows our cells to absorb glucose naturally released in our bloodstream from food and glycogen storage. This is not to be confused with type 2 diabetes, which is a metabolic condition where the body's cells become resistant to insulin. However, in both cases, hyperglycemia are exhibited. Type 1 diabetes is a world issue, as shown by the map provided of the mortality rate in populations of type 1 diabetes done by the NIH and ADA. A study that estimates the number of individuals living with type 1 diabetes was estimated to be approximately 8.4 million worldwide, with 500,000 new cases every year. By 2040, the number of people living with type 1 diabetes is projected to reach 13.5 to 17.4 million. Why exactly is a cure necessary for this community, though? The risk of type 1 diabetes complications like diabetic ketoacidosis, a condition that can be very fatal if not treated immediately, neuropathy, diabetic gastroparesis, coma, cognitive dysfunction, increased risks of dementia, cancers, and other autoimmune diseases, hyper and hypoglycemic episodes causing coma, strokes, seizures, or even death, device and insulin accessibility, tissue damage from medical devices, daily injections, etc., and increased burnout and mental health complications from the chronic stress that type 1 diabetes can cause on an individual. With those complications in mind, researchers, doctors, and the type 1 diabetic community have been looking to every innovation in biomedical sciences possible for a cure. One of the most promising of these innovations is a concept called stem cell therapeutics, which can be defined as extracting a specialized type of cells that have 2 or more important properties. They are able to create more cells like themselves, that is, they can self-renew, and become other cells to do different things in a process known as differentiation, according to Mayo Clinic. The goal is to ultimately create a new generation of insulin-producing beta cells by mimicking the in vivo development of the embryonic pancreas. In the case of trying to cure and treat type 1 diabetes, stem cells can be autologously collected, meaning extracted from our own bodies and innovated, typically using immune-sparing approaches to help disguise these cells and protect them from being attacked again by the immune system, then placed back into the patient's muscle tissue or organs via the liver and or pancreas in hopes of regaining the capability to produce insulin. All this brings to question if this concept has been applied successfully in humans yet. Luckily, in a groundbreaking trial, Dang Hong Ki, a cell biologist at Peking University, and his team took cells from 3 people living with type 1 diabetes and reverted them to the pluripotent stage, meaning that they could develop into any type of cell. This technique, originally developed by Shinya Yamanaka at Kyoto University nearly 20 years ago, was modified by Deng's team to use small molecules instead of proteins, allowing for better control. They used chemically reprogrammed cells to create 3D clusters of insulin-producing islets, which were then tested for safety in animals, and in June 2023, the team transplanted about 1.5 million islets into this woman's abdominal muscles, a new approach as most islet transplantations are done by the liver. By placing the cells in the abdomen, the team could monitor them with MRIs and remove them if necessary. The operation took less than 30 minutes total. 2.5 months later, the woman was able to produce enough insulin on her own and has continued to do so for over a year. Her blood sugar levels were 98% in range, eliminating dangerous spikes and drops. Many diabetes researchers have called this result remarkable in hopes that this approach can help more patients. However, many experts also stress that more people need to be tested, and that it can take up to 5 years of consistent insulin production to consider her fully cured. The team and scientists have also stated that 2 other participants in the trial are also doing well and are planning to expand the research. The woman was already taking immunosuppressants due to the liver transplant, and so the team couldn't fully assess whether her body would reject these new cells. Although there were no signs of autoimmune attack, the team is still working on ways to prevent cells from this risk, which is a common issue within type 1 diabetes. In a clinical trial done by the pharmaceutical company Vertex, a total of 14 participants completed at least 12 months of follow-up and were included in the analysis. In the beginning, C-peptide was undetectable at baseline in all 14 participants, but after the stem cell infusions, all participants had engraftment of islet cell function as evidenced by the detection of C-peptide, a marker for insulin production. However, 2 deaths occurred. One was caused by meningitis and the other caused by severe progression of pre-existing neurocognitive impairment. All 12 participants in Part B and C were free of severe hypoglycemic events, meaning low blood sugar incidents, and had a glycated hemoglobin of less than 7%. These percentages spent more than 70% of time in their target glucose range. 10 of the 12 participants had insulin independence and were not using exogenous insulin in a year. The results of this small short-term study involving people with type 1 diabetes support the hypothesis that stem cell research and transplantation can restore the physiologic islet cell function, warranting further clinical investigation. In sum, it is very exciting to say that as innovations in biomedical sciences progress, the closer the day comes when type 1 diabetes turns from a chronic illness to a condition that can be treated and cured effectively and immediately, which is why it's so important to continue supporting the institutions and programs that work to get closer to a cure for the millions of people around the world living with type 1 diabetes and the complications that come from it. Here are my references, and thank you so much for listening. If there are any inquiries, please feel free to reach out to me via LinkedIn or email. Have a great day.